So, we all know what mammals are, right? I would hope so, at least, seeing as how we humans are mammals. But if you happen to be watching this with your pet lizard or bird or that one weird uncle that you're not entirely certain isn't an alien, then I'm not going to make any assumptions about my audience. Mammals currently fill the role of dominant life on the planet. That doesn't mean that they're the most numerous by any means, but it does mean that they fit the top of the hierarchy. If you look out across the plains of Africa, the first thing that you're going to immediately see are going to be the lions, the zebras, the elephants, the big animals. And they're almost always mammals. Meanwhile, the birds, insects, and reptiles outnumber them by a vast margin. But they're not the first things that you think of whenever you imagine them. That's what we're talking about here. All the major ecological niches are filled by mammals. So how did we get here? We know by looking into the past that mammals weren't always on top. Dinosaurs filled that role for a significantly longer amount of time. Of course, we all know how that ended for them. The Cenozoic era occurred after the KPG extinction and is our current period of geological time. It's split into 3 periods with 7 epochs. And while I'd like to simplify things down as best I can to avoid hard to pronounce words, I'm going to have to talk about them because they are significantly relevant. But before we dive into that, we do have to talk about mammals prior to the KPG extinction. I will be brief on this. As covered in this video here, there. Mammals are synapsids. They first show up in the Triassic period, and by the time that the end of the Cretaceous rolls around, they had already diverged into the 3 major types that we know of. That's placental, marsupial, and monotremes. And that's where we're going to start our story with the rise of mammals. The Paleogene is the first period of the Cenozoic. It started just after the KPG extinction and lasted up to 23 million years ago. This period saw a massive amount of diversification with mammals and birds. In fact, just about every family of bird came about within the first 4 million years of the Paleogene. Wait. Why am I talking about birds? I refuse to make another video about birds. This is supposed to be about the rise of... The diversification of mammals didn't really start until the middle of the Paleogene, with the Eocene epoch, between 56 and 34 million years ago. The changes in the ocean currents allowed for whales, which had already become fully aquatic, to grow to massive sizes that they're known for. And the changes in global climates allowed for massive grasslands to form, opening up new ecological niches in the Oligocene epoch that quickly followed. This 10 million year period saw the first elephants, cats, dogs, and other mammals that you and I would be quite familiar with today. The Neogene is the next major stop for us in this journey. It lasted from 23 to 2.5 million years ago. Here we start to see the real results of the diversification that occurred earlier in the Cenozoic. While their early ancestors all emerged in the Eocene and the Oligocene, it's here in the Miocene epoch that we'd see what we'd undoubtedly recognized as modern mammals. True horses, apes, and of course my favorites, the otters, which you can see more about in this video. But none of these are really the major developments that we focus on when the Neogene is talked about. The end of this era is probably most important to us as humans, and that's because we started in the Pliocene epoch with Australopithecus. It could be argued that from this point on, everything is viewed in accordance to its relationship with human evolution. But we really aren't in the age of humans yet. The Pliocene still holds a number of significant events that doesn't include us, like the Great American Interchange, where the species that had evolved in North America and South America started to commingle, and it caused a lot of chaos. There's a number of mass extinctions. Well, I can't really say mass extinction. It's more localized extinctions that occurred because of this event. And the reason that it happened is because South America and North America finally join together. In fact, that's a major thing that occurs throughout the entirety of the Cenozoic era, is that most of the modern land masses that we know are starting to come into formation. Anyways, let's move on. When most geological ages end, they coincide with a mass extinction of some form or fashion. But up until now, I haven't really put any focus on them, largely because the ones here in the Cenozoic are very straightforward and typical. It's almost always climate change, but not to the same degree as what we're currently dealing with right now. The naturally occurring climate change of the Earth is almost always comes in cycles that are easily calculated or are intrinsically linked to specific events in the geological record. The end of the Pliocene, however, it's kind of funny because it's very similar to another mass extinction event. If you remember from this video up here, I mentioned something called the Eltonine impact. It was an asteroid impact off the coast of South America at the end of the Pliocene. It was only about 2.5 to 3 miles wide, making it significantly smaller than the one at Chicxulub, but it still had enough energy to trigger tsunamis and to disrupt the already cooling weather patterns enough to trigger an ice age. But this isn't the only event that occurred at the end of the Pliocene. Supernovae are really cool to observe, but when they're in your galactic backyard, they're a bit life-altering. The current data suggests that in addition to the Eltonine impact, there was a massive spike in the indicators of relatively nearby supernovae. Multiple of them. And they would have only exacerbated the problems that were currently occurring before the asteroid impact. The Quaternary is the final era of the Cenozoic, and it's where we find ourselves. It's here in the Pleistocene that we start to see things like mammoths, saber-toothed tigers, and dire wolves. But we also see the diversification of hominids. Homo erectus, Neanderthals, the rest of our early ancestors. Oh, and modern humans. We show up roughly 300,000 years ago. All of recorded history lies within the Holocene epoch, which started roughly 11,700 years ago. Unlike the other epochs of the past, it's not hallmarked by any major change in evolution, but given just how short it is, I mean, that's kind of understandable. Instead, it's recognized by ecological changes, extinctions, and shifts in diversity of plants and animals, the majority of which is solely attributed to us. Recorded history seems fairly vast when you look back upon it, but it only makes up 3.9% of humanity's total time on the planet. And it's only 0.017% of the age of mammals that we've been talking about in this video. I am certainly not about to shift focus of this video onto human history. That would be exhausting. And as you can see from the little bar at the bottom of it, we don't have time for that. The Rise of Mammals is a story of endurance and perseverance, much like this YouTube channel. Man, how many times am I going to make a stupid pun about this channel and extinction? Oh, just subscribe already. Anyways, I'll see you next time.